Good afternoon, everyone. Welcome to the Transformation of Residential Circuit Protection webinar. My name is Kate Adamczyk, Head of Marketing at Rexel, and we have Kieran White, the Category Manager from Schneider, who will be taking you through the webinar. If anyone has any questions, please just pop them into the questions box, and we will then get to them at the end. If for whatever reason we don't manage to get through all the questions and we miss yours, don't worry, we will contact you separately to make sure that all the questions are answered. So I will hand over to Kieran now and enjoy the webinar.
Thank you very much, Kate. Good afternoon, everybody. As Kate said, my name's Kieran White. I'm Category Manager or Offer Manager at Schneider Electric with special interest in residential circuit protection. First of all, before we go any further, I probably need to apologise if you can. I did get a positive test for COVID this morning, so I am full of the virus. So I hope it's coming across clear enough. And secondly, I can see the size of my head in the webcam, so apologies for that. But we'll go through the presentation and the webinar. And as I said, it's transformation of residential protection, and it's just to highlight how things are changing moving forward. The first slide is just an overview of Schneider Electric globally. Some of you may or may not be aware that we're such a global business. Lots of figures on the screen there. I won't go through them. Just to say that we are very balanced global presence across the whole globe. Key figure for myself there is that first figure of 5% of revenues devoted to R&D. And that's very important for a manufacturer to reinvest in future technologies so we can keep up to date with regulations, ensure that we've got the right product for the market as the market changes. And considering our turnover in 2020 was 25.2 billion euros, the 5% of that is quite a large sum. So I say that it's a very nice figure for me to be able to ask the business for to develop more product for the market. Globally, 41% of our revenues are in new economies, and globally we have over 128,000 employees based in over 100 countries. So that's the global view. Back to UK and Ireland. As it says there, we start our roots in the UK 1937 with Yorkshire switchgear. And just some key figures there: turnover 2 billion, 9 manufacturing sites, 2 international distribution centres, and over 4,000 employees in the UK. And again, if you look at the map there, you'll see how well kind of we are represented across the UK, where we have our manufacturing sites, our offices, and our outlets. So, transformation of the commercial environment, again, just a nod to our commercial side of where it all started with that. For those of you who've been in the industry as long as I have, which is 30 years, they may remember some of the devices that are on the screen now. So the F70, the F32, the Multi-9, C32, and then the C60 commercial MCB. And then coupled with that, we had the launch of the Multi-9 isobar, which again, you know, 1990, 30 years later, we're still the only people in the market that has an isolating bar on the main fishbone. And here we are all the way up to modern day. So in 2005, we launched the isobar 4C. 2013, we launched Acti9 and Acti9 isobar. And in 2018, Acti9 isobar P with our plug-on neutral for commercial RCBOs in the distribution boards. So that's just a nod to our commercial part of the business. And if, oops, excuse the spelling mistake. So if you look at the consumer unit history with Schneider Electric in the UK, so pre-2001, here at Schneider Electric we used a square T format with the plug-on MCBs, and then we moved on in 2012 to the Easy9 plastic consumer unit. And then, as we're all aware, in 2017, I believe, the regs changed Amendment 3 to have metal consumer units. So to ensure we had the right offer for the market, we came along with the Easy9 Plus, and that was our first metal consumer unit in the Easy9 range. And then in June of this year, we launched the Easy9 compact consumer unit. And as the name suggests, it's a smaller footprint than the Easy9 Plus, and it's specifically designed for the rewire refit market, where space is at premium under a cupboard, under the stairs, where the existing consumer unit was. So some key dates with BS7671, and obviously this is the book that we all adhere to when we do design, install, maintenance. We're on edition 18 at the moment, amendment number 1, and amendment number 2 is coming out shortly. But if you look at the timeline, the 18th edition was published in 2018. Enforcement started then on the 1st of January the following year. Amendment number 1 came on the 1st of February 2020, and again we have a 6-month bedding in grace period to ensure that your designs are up to scratch. So by the 1st of August of that year you had to comply. And then important thing at the moment is the draft for public comment was open on the 21st of September 2020. So as and when the regulations BS7671 are updated, the BSI and the IET, they release a document called the draft for public comment, and it's available to anybody in the open environment to download and to read and to have their say on the potential changes that may happen in the future editions of the wiring regulations. So it's a very important document, the TPC. As I say, if you have an idea where you'd like the circuit protection environment to go, the installation protecting the installation arena to go, then that's an opportunity when the DPCs are released before an amendment to have your say. And if there's enough people get behind a certain issue or a certain concern that they have with the regulations, then the board and the group will look at it and make a judgment on it. So that was 21st September 2020, and then that draft for public comment closed on the 11th of December 2020. So a couple of months there just for people to download, to have a look and make their comments. So since it closed in 11th of December 2020, behind the scenes, the IET and BSI have been in rooms and they've been pulling apart the various different inputs that people within the electrical industry have fed in, and the anticipated published date is estimated as spring 2022 for the amendment number 2. And as you can see from the screen there, it's going to be the first consolidated amendment, so we're going to be changing the book cover to brown. And of course, just like the other edition and the amendments, there's a 6-month grace period for where you have to ensure your designs comply or your installations comply. So before I go any further, as I said, I'm going to talk through a couple of the regulations that were in that DPC. So I appreciate it was a year ago and a lot may have changed, and certainly to do with AFDDs, they seem to have changed. So take this next slide with a pinch of salt. It's just there to highlight the fact that in the residential space, the regulations seem to be going down the route of increased safety by adopting some additional measures of AFDDs. Now, as on what they're going to be, we don't know at this point. As I said, the amendment number 2 comes out next February. So what we'll have is, we have this kind of limbo stage at the moment where we don't know what the regulations are going to say. Are they going to be adopted? Are they going to be compulsory? But before the decision was made, this is what the original DPC said, that it was a requirement and no longer a recommendation to provide AFDDs for single phase AC final circuits. So that's what it said originally at the DPC last year, but reliably informed that that's going to be updated when we have, seems to be a lot of pushback from AFDDs in the market at the moment. Another regulation is around transient over voltages and the use of SPDs, again in the residential environment. We'll go through a few of these. Is the regulation that gives the circumstances in which protection of SPDs shall be provided. The text has been simplified. So previously there's you had to do a calculation, risk level, to see whether or not it was used. but they've changed the wording, or they're proposing to change the wording, and it says it may not be fully confirmed yet, so we need to wait and see till next year. So it's simplified, and it's been a bit more direct. So protection shall be provided where the consequence of overvoltage could result in serious injury to or loss of human life, including safety services, and significant financial or data loss. So they simplified it there, and this is quite an interesting line. Except for single dwelling units, a risk assessment is required for all other cases where consequences of overvoltages are considered intolerable. Okay, so the first bit there, except for single dwelling units. So the last line of the proposed regulation, which will have a direct impact on the residential arena moving forward, is protection not required for single dwelling units if total value of loss therein does not justify this. So what the reg's saying there, you don't have to put an SPD in if you can justify the fact that that additional, what it may be, 50, 60 pound for a SPD outweighs the cost of the potential damage that could happen within that property. Now, as electricians, I'm an ex-electrician myself, certainly in the domestic arena, if you're doing a rewire, you take on the design responsibility when you look at doing a rewire or a new install. So that's down to you. So the regulations are trying to tighten up on it, but that last bit there, protection not required, single dwellings, total value of loss therein does not justify it. So it's getting very hard to justify not putting one in. So here's another regulation, 531.3.2, unwanted tripping. And again, these are subject to change. A new indent has been added. The indent requires that the consideration shall be given to the use of RCBOs in domestic installations in order to help minimise the effects of unwanted tripping. So in essence, what this regulation is saying is, whereas we currently have a populated board with maybe two dual RCDs with downstream circuits, if a item of equipment causes one RCD to trip, then obviously you will lose all the other circuits downstream of that RCD. So especially within the residential environment, it's saying consideration, sorry, the domestic environment, same thing, consideration should be made for use of RCBOs. And if you see over the years where we had RCDs come in as a split board, where you had a main switch, and then you had some unprotected ways, and then you had an RCD with protected ways, and then we went to two RCDs fully protected on the ways, high integrity if you need some something that's not going to lose the power if you're tripping. And here we are now, where we're actually saying the market's going to be all for increased safety consideration for RCBOs. So what we'd be looking at is a consumer unit. That's our compact consumer unit. Main switch, I fitted this with an SPD, so we've got an overcurrent protected device as an MCB, and then a series of RCBOs. Now, I fully appreciate not every job at the moment would be able to carry that kind of additional costs, but as we see with the regulations, they tend to drip feed an idea, and then over the coming amendments, it's slowly enforce. So who knows what's going to happen with amendment number 3 or even the next edition. So regulation 531.3.3, the types of RCD. So again, if you remember when RCD, or if you can remember when RCDs first came out, it was new technology. It was deemed maybe overkill, wasn't really required. The MCB was come great ways with the MCB to improve safety, disconnection times, and then we came along with the RCD, which tripped out the circuit in milliseconds, and that was we're talking probably 30 years ago now. And at the time, the majority of loads in the residential, potentially in the commercial as well, were resistive loads. We hadn't really embraced the full technology we have today, or the technology wasn't around. We had DC components within the network. So what this is about is the regulation that points out the different types of RCD. And again, as a designer, you need to ensure if you're designing, installing, that you choose the right one. So it also states only a type A RCD may be used for general purposes. So because of the increase in electronics in our circuits, things like charging units, computers, IT, they're imposing, those devices impose a DC current back onto the network, and that has an effect of what we call blinding the RCD and causing it not to operate effectively. So moving forward, the regulation saying only Type A RCDs be used for general purpose. And at Schneider Electric, EZ9 residential RCBOs have been Type A for 2 or 3 years now. And then to counteract that, Type A RCD should only be used to serve equipment where it is known that the load contains no DC components. And again, it could be a bit ambiguous, but what the regulations has said is that it's actually given some examples of heating appliances, filament lighting, so you can make that judgment call whether or not it needs to be a Type A or a Type AC. And then for those who aren't aware, that the Type AC there is obviously the sine wave for the AC. The A is the sine wave and the DC ripple. It'll see a DC current up to 6 milliamps. And then we have the F type, which who knows in the next 4 or 5 years, the industry, the regulations will be saying we need to look at F type, which again has a greater tolerance for DC on the network. And then Type B RCDs are used for EV charging. So it's just a regulation just to highlight the fact that there are different RCDs, and you need to be ensure that you're selecting the right one for the application. So the next chapter is the next bit I want to talk about is chapter 82, and it's about prosumers low voltage electrical installations. And this is where the transformation in the market really is starting to change, because what we're seeing is, I mean, so the prosumers low voltage electrical installation is where we have an installation, a property that has multiple sources of supply. So we're talking things like PV, a grid connection, could be battery storage, could use your car as a storage device, and how that affects and how that works within your home environment. So it's a completely new chapter. It deals with prosumers electrical installation. The term prosumer is defined in part 2 as an entity or party which can both produce and consume electrical energy. So whether you're producing energy via a photovoltaic grid on your roof, you may have a small wind turbine, you're using battery storage to charge when you're not on peak time, and then utilize that energy when you're back into peak time. That's what this chapter is talking about. The new section gives requirements and recommendations for electrical installations that incorporate local production and or storage of electrical energy. Such installations will be able to operate in direct feeding, reverse feeding, or island mode. So island mode is where you completely set aside from the grid, so you're generating and using your own energy. And again, who'd have thought that 15, 20 years ago we'd be in a situation in the UK where that is a potential. The reason for the transformation in the residential protection is because of this gentleman here, Chris Skidmore, back in June 2019. He signed a mandate, so legally binding, that by 2050 the UK homes in the UK would be net zero, and it's 2045 in Scotland, I believe. So it's a mandate, as where it's legally binding, it's in law. So with that in mind, we currently have 26 million homes in the UK which require getting up to a net zero level C standard. And a couple of big influences in driving the change is that in 2025 there'll be no gas heating in new builds. So in new build houses they'll be going to air source heat pumps. You'll still be able to get a replacement boiler for your existing one, but it's a more efficient and it has less emissions, the air source heat pump. In 2035, diesel and fuel vehicles will be phased out, and all sales of cars and vans will need to be ultra low emission vehicles. So if there's any electricians on the line and you've ventured into the world of EV and putting EV charge points in, maybe you've seen your business grow massively in this area. But again, to reach our target by 2050, there's some drastic changes that the government have implemented, and one of them is the reduction of fossil fuel burning vehicles. So that's going to put even more. So we've got two items there that put more strain on the grid: electrical heating source as opposed to a gas-fueled heating source, and then the removal or the introduction even of EV chargers around the UK. So the load in the system is only going to increase. Figures state that by 2040, domestic electricity consumption will over triple. So yes, appliances may be getting more efficient, but we're actually using more of these appliances. If you look around your home or even your office, you know, there's barely a spare plug these days. It's got a charger in, it's got you know, an iPad charger, a phone charger, something plugged into it. And again, that's going to, part of that over 3 times increase in energy will be down to the EV charging and the removal of gas boilers. And as I said right at the start there, in 2050, all homes will need to be EPC rated, EPC C rated or higher. So if you think we have a housing stock in the UK of 26 million homes, and then by 2050 there'll be additional 6 million homes, there's a lot of work to do between now and then to get our buildings up to net zero or net zero level C. So future homes and what needs to be done. So this is a publication from Electrical Safety First, and what it does, if you look at the screen there, you've got many different sources. So if we take out number 1 first, internal wall and loft insulation. So from the electrical industry, we don't normally deal with the fabric side of the business. It's very important, and moving forward for net zero, we'll probably be looking at something like additional cladding on the external side of the building, and obviously we're probably all well aware that the minimum depth for the requirement to put minimum depth of loft insulation to ensure we minimise the loss of heat through the roof space. But then if you look down number 2 there, the heat pump, as I mentioned, so that's going to be the heating source in the home. Solar panel, solar PV and battery storage. So you're going to generate on site by means of a solar panel, photovoltaic, and then that energy, depending on the requirements of the household, is whether we use that energy straight away or whether we store that energy. And there's a couple of ways of storing it. It can be battery storage, as you see in point 4 there next to the car, or it could be a thermal storage, so it could be a hot water tank, excuse me. It could be a hot water tank where you actually heat the hot water whilst your energy is being generated for free, and then you have the ability then to draw off that water later on. But the important thing as well is to look at number 5 when you see all the connected devices. So I myself have some connected lamps in my house, whether it's on my smart speaker, I better not say the name, or whether it's on, you know, whether it's controlled by your phone. But moving forward, the appliances in the home will need to be controlled so we can make best use of the available energy when we have it. So like I said, if we generate energy during the day when everyone's out of work, it makes sense then to maybe do some of the processes, heat the hot water up, charge the car, maybe put a wash on whilst that energy is free, and then capitalize on that energy when you're back home and it's on peak and you can draw off those storage devices. Interesting to point out there, this Electrical Safety First report, they do talk about the safety requirement around turning appliances on when you're away from home. So it's, you know, it's a journey we need to start. People like this have started the conversation. Schneider have started the conversation, and we need to find that road where it's going to be safe to use the energy. It's going to be controlled and it's going to be efficient. So that's a very important slide moving forward. And then one of the lines in that report, and I've taken out just to highlight here, is that the domestic building stock and personal transport will be critical to meeting our climate change targets. The challenge is significant, and the UK needs to retrofit approximately 26 million homes and over 38 million cars in the UK will have to be replaced by ultra-low emission vehicles. So that's you know, I mean, if you look out in my road here, every drive's got a car on. That's what we're going to be looking at moving forward. And then residential circuit protection of the future. So with this slide, it makes sense that if all of the energy sources, if all the items we wish to control, the PV, the battery, the water heating, is all done via the electrical system, it makes sense that the consumer unit be the central hub for all that energy. So moving forward, we'll have the residential home system will have a connection to the cloud. So we'll have some intelligence based in the home, some kind of controller, smart controller, which will take the inputs of how much energy is being created from the solar panels. So you know, we'll have that analytics in the cloud. When required, we'll draw energy from the grid and pass energy to the grid. Very important, bi-directional. Talked about EV, where not only do we charge, but again, off peak, we may be able to use the car as a storage device. Bear with me a second. We have battery storage. Again, you may hear of, I think Tesla do batteries, there's some other manufacturers of batteries now, and the idea is that you store that battery in off-peak times and capitalise on the savings moving forward. We have metering. Very important, we need to understand what we're using so we can use it more efficient, make best use of it. Electric thermal storage, as I said, it's a tank of hot water. It's using that energy generated from the PV and making a heat source out of it. Air source heat pump, which is your old gas, well, we'll replace the old gas boilers. And we have photovoltaic as obviously one of the sources of energy moving forward. So just like everything else in this day and age, we want to be able to control it. We want that functionality to be able to control it on our app, control it from our iPad, and moving forward, residential circuit protection will have to include that kind of feature. So in closing, future circuit protection will have to give us control. It will have to give us visibility of what's going on within the home. And if we get those first two right, it'll prove to be efficient and will make best use of the energy available. So that's the end of the presentation. If there are any questions, please put them in the chat box. Okay, can you see any coming through your side? Okay, someone's put a question about AFDDs, and they are quite a sticky topic because certain groups in the industry don't believe in their full effectiveness yet. They don't believe it's been fully approved, and there's certain types of installation where they believe that it may not identify the fault. So with our fault detection devices, the device looks for a repetitive shoulder on the sine wave, and that repetitive shoulder, if it sees it so many times, it will trip the device. Whereas if you've seen some articles on YouTube where people have tried to recreate it and they've put two cables together to spark and it hasn't tripped, it's because it hasn't seen that repetitive arc on the sine wave. Okay, Any more questions?
There is one more question, Kieran. Any updates on Schneider electric EV chargers?
Yeah, we're Schneider Electric, we're constantly evolving our offer. The EV market, as I said, is moving massively fast at the moment. If you take those that person's details, we can update them with the latest offer. It's not on a particular offer, but I can certainly get them some information and push them that way.
Perfect. Anyone else got any more questions? You have just put them in the questions chat box. No? Okay. I think that's everything then, Kieran.
Okay, thank you very much for your attendance.
Thank you, everyone.
Cheers. Bye-bye.
Bye-bye. Bye-bye.